in the breaking down fate pathway, the critical enzyme here is an enzyme called phosphofructokinase, or PFK. And as the name implies, its job is to transfer yet another phosphate onto this glucose that already has one phosphate group onto it. So it's going to add a second phosphate group onto it. And this enzyme is allosterically regulated by both ATP and ADP. So let's think about this for a second. ATP and ADP. So if ATP levels are high, it doesn't make sense to break down glucose to make more ATP. Remember, ATP is a short-lived, it's a very unstable molecule. It breaks down very rapidly. And so it makes more sense if the cell has a lot of ATP just to save that glucose, sort of put it in the bank and extract energy from it when it actually needs to spend that energy. So based off of that, hopefully it makes sense that ATP is going to allosterically inhibit phosphofructokinase. It's going to bind to a non-active site location. It's going to distort the shape of the enzyme, and it's going to make phosphofructokinase unable to catalyze the reaction that it's wanting to catalyze. On the other hand, if ATP levels are low, then that by default means that ADP levels will be high, because what do you get when you break down ATP? You get ADP. So if ADP levels are high relative to ATP levels, that indicates that there is an absence of energy and that the cell needs to boost its ATP levels back to an optimal level. And so ADP is going to allosterically activate phosphofructokinase. It's an allosteric activator. It's going to stabilize the shape of phosphofructokinase so that it can more easily grab onto the substrate. And in this case, the substrate is going to be the glucose that's already been phosphorylated and another ATP. So one of the important things to remember in this process, and we're going to call this process glycolysis. Glucose. Lysis is to rupture or to split. So we're going to split the glucose apart. The important thing to keep in mind here is that the cell is actually, up to this point, the cell is actually spending energy, right? The cell is spending ATP in order to get glucose into a reactive state. Once glucose has achieved this highly unstable reactive state, then the cell can actually begin extracting energy from glucose. So it's important to keep in mind, though, that up to this point, the cell is actually investing energy rather than getting any energy out of this, but that will change very shortly. Okay, so here's a substrate for phosphofructokinase. It's the glucose with the phosphate group attached to it. Another substrate is going to be ATP. It's a kinase, remember. So by definition, what a kinase does is it transfers a phosphate from ATP onto some other substrate. And so the kinase, the phosphofructokinase, not drawn to scale. The kinase itself is massive compared to the actual substrates, but you get the idea. Phosphate is going to be removed. Obviously, this is going to release energy. That energy is going to be used to attach the phosphate onto glucose. So now glucose has two phosphate groups on it, highly unstable, highly reactive. This glucose is going to split. There's an enzyme that's going to come in and now split glucose in half to form two 3-carbon molecules. So that's going to happen almost immediately after glucose is phosphorylated. Now remember, all of this is happening in the cytoplasm. Glucose comes in, phosphorylated once, and if PFK is active, it's going to be phosphorylated again, and almost immediately after that, it's going to split right in two. And so let's draw the two byproducts. I'm going to draw sort of the line stick method, or the technique for drawing these atoms, or these molecules, I mean. Each one of these black circles represents a carbon. Now remember, we're splitting glucose in half. Glucose had 6 carbons, so these two molecules each have 3 carbons. And let's not forget that each one has a phosphate group attached to it. Right? So just imagine taking this glucose molecule and just chopping it right in half after it's been phosphorylated for the second time. We call these molecules G3P, or glyceraldehyde 3-phosphate. The 3 is referring to the fact that carbon number 3 has a phosphate group attached onto it, G3P. The production of G3P marks the end of the energy investment phase of glycolysis. So when you think of glycolysis, there is an energy in phase and there is an energy out phase. So the energy in is the initial energy that has to be invested into glucose to make it unstable and reactive. That is the cell spending 2 ATP molecules to get to this point. But once the cell gets to this point, the production of G3P, we have now entered the energy extraction or the energy coming out phase of glycolysis. And so that's what we're going to look at in the next video.